University in Charleston, Illinois. Now, when I was hired here 16, 17 years ago, I didn't know where Charleston, Illinois in the world. And that was one of the questions that the committee asked me, have you heard about this? How did you hear about it? I said, honestly, I have never heard about Charleston, Illinois. So they laughed at me and say, well, Fiq, work on your geography and history, because this is a place that you want to know its history and geography. The nice thing is that they hired me and they kept me. So I say this because maybe this video will be broadcast over the internet and people wouldn't know where Charleston, Illinois is, but please believe me, it is a wonderful place to be at. And I welcome you to the first Eastern Illinois University symposium on science and technology. And Dr. Stephen Daniels and I, Dr. Stephen Daniels, the chair of the physics department, who is joining hands with me to do this, we wish that this wouldn't be the last. It would be the first in a series of symposia, and we are grateful for almost 50 presenters, from a variety of topics that are giving us their hearts and their minds to share with us. So without much ado, Revolutions in Science and Technology Paradigms is the symposium, and Dr. Ping Lu is my friend and colleague, whom I learned a lot from him through these years. And without much ado, I'll give the microphone to him. And please join with me in
Thank you. Thank you, Dr. Wabi. And we appreciate that when we look at the program, I was so impressed that you are able to pull all the kind of talents together. And I cannot claim myself as talent, but I feel that it's an honor to be with this business group. So, and then my talk will be kind of illustrating the things how we did in the past with across the entire campus, and then what we are doing right now and where we are heading towards in the future in terms of clean energy research and education across the entire campus here. So it'll be very simple. My idea initially was that I will use those slides as a clue for conversation. And I personally don't like lecture, so I don't do lecture, and I do not do lecture well anyway. So, but I want to use those slides as a kind of a lead for conversation for us. So, and we all of us know that Eastern Illinois University has constructed our renewable energy center. We replaced the old steam plant and to supply steam and heat and some electricity to the whole campus. And so it used to be the steam plant was close to Old Main, but now it's on the far edge of the campus. I was told that back to the 1920s, and before probably Dr. Buhalu was born, that the old steam plant was at the edge of the campus at that moment. So you can see over about 80-some years, or maybe more than 80 years, then the campus has grown quite a bit. So hopefully that new spot will not be the edge in the future anyway. So, but with this kind of construction that the university felt that, or community felt that there are opportunities present for our academic units here. So there was back to about spring of 2010, there was a directive from the president and the provost saying, well, we need to integrate the opportunities brought by the Renewable Energy Center with our educational mission. That's what the president and provost have been talking about, so-called integrated learning, and they want to really push that. And so for some odd reasons, I don't know, and I was involved, and so I sit in the meetings and listen to the talks, and I sense the passion from the president and the provost, and in a sense also the some kind of passion also from our faculty and the chairs and deans. But anyway, the challenge there was that how do we systematically integrate the student learning process with those opportunities brought by the Renewable Energy Center? Right now it seems to be a very easy question, but at that moment it was really a kind of not debate, but it was kind of things that we don't know what we want to do. So eventually that the campus came together, mainly College of Sciences, because almost all the meetings were hosted in the College of Science Dean's office. And I was from College of Business and Applied Sciences, and I just don't know what's going on. But as a faculty member in your department, for example, Dr. Chris Langan has been participating in a meeting, and then your former chair, Dr. Stamek, and then before he moved to the Honors College, and he was also part of that meeting process. And your dean, Dean Hanna, and our dean Hoadley, they were all in that meeting with provost. And after several meetings there, and then there was a kind of consensus that the whole campus needs to form a cohesive effort and concerted effort in the sense to kind of integrate the opportunity we have on this campus. So that was a concept evolved, and the concept eventually evolved this thing we call the Center for Clean Energy Research and Education. And I had a hard time to come up with an acronym, but Mary Harrington Perry, and she has a PhD in English, and she said, well, you can do this. It's okay, you don't need to use all the first letters. So eventually we came up with a name called Sincere. And it's easy for us to pronounce and easy for us to use, but also it captured the spirit for the whole campus to work together. So that, to me, that works both ways, either correct or not, but it works together to pull all the efforts together across the entire campus. So with the research and education mission, I'll start with the education component, see what we did and how that evolves. So the first thing that Sincere has started supporting is the development of a undergraduate concentration, and eventually it was called Alternative Energy and Sustainability. And that's a concentration under our Applied Engineering and Technology undergraduate major in the scope of technology. Okay, so any questions so far at this point? Okay, no, it's pretty simple concept, but when you look at back, you'll see we have gone through a lot of details. And then we put efforts there, and then to develop we call interdisciplinary minor. That's a minor between College of Sciences and the College of Business and Applied Sciences. So basically, what we did was we pour some courses, or I should not say we, but the main efforts were done by Dr. Gaines and Dr. Langan in your department. And putting those efforts to say, pour the courses for the AET concentration, alternative energy and sustainability, and with some biological science courses and geology, geography courses, and political science, economic courses together to make a interdisciplinary minor. Okay. That effort was a kind of concurrent effort as we developed for a new graduate degree program called the Master of Science in Sustainable Energy. And this was developed based upon the work and experience we have enjoyed so much working with different people, different faculty members, students across the different departments. And so this is now becomes a reality that initially our thought was to pull all the efforts together for the entire campus to make this as a reality. The reason we did this was that back to early 2010, I happened to be on a seminar at Millikan University in Decatur, and the guest speaker was the director of Henry Ford Presidential Library, and he was asked to serve as a commission for the BP oil spill investigation. And so he was very familiar with that investigation issues and basically related to energy and environmental issues. And he made a very indelible kind of impression on me, because in that speech he mentioned that in order for us to solve energy problems, and we got to work together, we got to pull all the talents from different sectors. And he literally mean government agencies, communities, and different kind of disciplines there. And then so that kind of speech gave me a kind of impression I will need to work together with other people to come up with a solution. And sure enough, after I have done some research and found out really indeed any of those problems are no longer a simple problems. Probably Dr. Craig can mention that, can testify that, like just like a weather condition, that it's so complex. And a single person probably can no longer tackle this complex issue effectively anymore. So we need a kind of collective efforts for people to work together. So anyway, this program, as we develop it there, and it evolves, and the concept we had was that this degree being Eastern, being at the EIU, our niche is not the same as U of I. U of I being, for example, being a research institution, and they can produce lots of we call bench scientists. But being a liberal arts foundational school, now our niche is to provide students with technical skills or knowledge, at the same time providing a kind of a long-term kind of people skills as well. So it's a good combination of people skills and the technical know-how in the sense that makes our students marketable in the competitive world. So this program design was based on what we call science-based and then management focused. So those two combined together. So we hope that will make students very, very marketable. Because as I talked to Mike before this meeting here, and I feel that if we want to be valuable to an organization, and we got to be able to work with different people. We need to understand the technical details, but also we need to find ways to be able to work with other people. That way we can make a bigger impact for the organization or eventually for the society. So basically what we had was that, so there's a whole cluster of science courses in the program. So those were delivered by, say, physics, chemistry, biological science, and then technology. And then there's another cluster of technology management courses. And those were delivered by technology and business. And then for our students to be a leader in the future, they have to be able to communicate and be able to work with other people. So that's why you can see English and political science, English and communication studies. They are also part of that program. They provide a course on communication studies in the technical disciplines. And then I have to also understand the political, it's geopolitical and those kind of issues there. So that's why we have geology, geography, economics, and political science that deals with one cluster. I call it policy and economics cluster. Yeah, so you have several clusters in that whole degree program. We hope that students will be able to develop their niche before they graduate. And then this degree program is under Sincere, and so it heavily focuses on research, but also it provides the students a required practical experience to be done at a renewable energy center. And this is something that's very unique in this country, that if you look at, for example, any medical school, for example, all the medical schools have their own teaching hospitals. But on the other hand, if you look at any college of engineering or college of sciences, you probably don't have any practicing factories, or you don't have any practicing companies on your campus. But with the Renewable Energy Center here being present on campus, being utilized here for this degree, then students will be able to do their practical job shadowing within that facility. So that becomes our teaching laboratory in a sense, a teaching factory in a sense. And so that becomes a very unique feature for this new degree program. Okay, so any questions? Any comments?
And we also will have a new building at this point.
Yes, that's coming up. I will talk a little bit on that. That will present some new opportunities for our faculty and students. As a matter of fact, did any of you attend the faculty reception yesterday by the president and the provost, faculty senate? Okay. And the president spent quite a bit of effort, quite a time talking about Sincere building yesterday. And he mentioned about the idea that EIU has created the Renewable Energy Center, and the Renewable Energy Center has brought many opportunities for us. So this kind of is a more elaborate version of his talk yesterday, talking about the Sincere part. So, but I'll get to that portion for the Sincere building. So thank you, Dr. Puhalu. Okay. So currently we have, with this effort, we have several research efforts concurrently going with Sincere and with other faculty members across the entire campus. And so this is a biomass education research project. It's a project funded by the National Science Foundation. It's a 3-year project. And so that we are now in the middle of that project right now. Okay, so, and what you have seen is this is a biomass gasifier that converts a biomass, like for example wood chips or say grass pellets, into syngas that contains carbon monoxide, hydrogen, and methane gas. So, and then that's the same type of mechanism that you will see in the Renewable Energy Center. Over there are two major gasifiers that can convert, say, wood chips into energy, and then you burn the energy to generate steam and partial electricity for the campus. So we hope that we can use that. But by the way, that the gasifier was purchased with a support from Charleston Area Charitable Foundation. And the reason EIU was able to secure the funding initially was that we want to study different biomass stocks, and hopefully we'll find alternatives for the Renewable Energy Center. And then with that solution there, we hope that we can promote farmers in this region to grow energy crops, okay, or some other. We can also get some energy from the crop residuals. For example, corn stover would be one example to get those energy out of the residuals from the agricultural process. So our hope is to kind of use the Renewable Energy Center at the EIU as an economic engine to drive this whole region. So this is a second, the other project funded by URI's Illinois Sustainable Technology Center that deals with grass pellets gasification process. It's a further step of our project from the National Science Foundation. And what we do on this here is that we deal with grass pellets like miscanthus and switchgrass, and make them into pellets, and then see how we can gasify them and then to reap the energy value from the process. And then look at the energy production, and we also have to look at the systematic way, or a kind of a sustainable way to continuously sustain the operation. So the gasification is one part of the game. The other thing we have been looking at is that Dr. Wabi is also in this project. This is a way of looking at how do we dispose the ash. And how do we utilize the ash coming out of wood chips or other biomass? So even though, for example, the emission of utilizing biomass is much lower than coal combustion. Coal has a very high content of silicon oxide and then calcium oxide. And so because of that, the ash content is much higher than biomass. Biomass has much lower content on that. However, regardless how small it is, but over the years, you're going to generate some biomass ash. For example, the capacity designed for the Renewable Energy Center here at the EIU is we are going to consume 30,000 tons of biomass every year. 30,000 tons is not a very small number. And if you look at a very low concentration of ash, for example, if you take 1% as one example, then you're talking about 3,000 tons of ash. And 3,000 tons of ash may not be very huge, but if you look at the cost for dispose to landfill, in average is about $85 per ton. And so Eastern has to pay for those if we don't find ways to dispose them in a responsible way, because we want to do that anyway. We want to do it in a sustainable and responsible way to dispose those ash there. So one of the ways we have this the project was also sponsored by Illinois Sustainable Technology Center at URI, is that we are looking at the ash, how we can add those ash as additives to make concrete structure materials. For example, could be a brick. Actually, this is a research project is collaborating with the ISTC people there, and ISTC staff are doing applications for brick structures. So we are doing cement applications. So we are kind of, those two teams converge our thoughts and our findings together. Then the main purpose is to find applications for gas, again, biomass gas, ashes. Okay. So that's another real practical application for the projects we have. So those 3 projects are all funded by different agencies and for Sincere. And then in the process, we also were able to involve undergraduate students as part of the research. And because I can see this is not only Eastern, but also a national movement that all the colleges are putting a lot of emphasis on undergraduate research, because that will make our undergraduate students much, much more marketable in competing for graduate school or competing for professional schools or even the jobs in the marketplace. So this is one example that we are able to involve undergraduate students for the research. I'm glad that Mike is doing that and for your research. It's an excellent thing to do. Okay, very smart move. And the other thing that is that we not only have support from different agencies also outside the university, but also we partner with different, say, private companies. And so this is one example that we partner with a company that we work with recycled wood. And how do we convert the recycled wood into a usable form? So in this particular case, we try to use them to kind of hammer mill and grind them into small pieces before we make wood pallets. Okay, so that next picture you can see those are the wood pallets made by those graduate students team. And so then we can gasify those, put into the gasifier and convert them into gas. Okay. If we don't do it, then the question why do we do it is that if we don't do it, and then the material you have or the fuel you have is not going to be very consistent, and then it's not easy for you to control the gasification process. In theory, we could do it. We can gasify whatever carbonaceous material we have, but it's not easy for us to control. It's not going to give you the efficiency, so it's not going to be practical if we don't have a consistent form of the fuel. So, any question on this?
I wonder if I can, if this might relate, because I know one of the things that I've been hearing the questions is how we get past some of the difficulties in obtaining or using materials like corn stover that you mentioned.
Yes.
Can you talk about what some of those issues are? And how
Yes.
they might be fixed?
We have just last semester we have studied a plant called Arundinodonax. Arundinodonax, I'm not a biologist, but look at the kind of shapes there. They are very similar to Miscanthus, but much, much bigger and more like a bamboo. Okay. The reason I want to mention that is that we simply chop those Arundinodonax and put it into a gasifier, and marginally we could gasify them. However, it's going to be, the control was much, much more difficult, much tricky, and the combustion process happening in the gasifier is more violent in a sense. So the long story short, to answer your question, first of all, there's one technical issue, that is the consistency. If I collect the corn stover, for example, after we chop them, and you see leaves, you see stems, you see cobs, and all different things come together, and there are different forms. The leaves are much, much more difficult for us to control in terms of internal, in the combustion process. Gasification needs some combustion, so it's very difficult to control that combustion process to make it steady. So I would imagine that it's not conclusive yet, but I would imagine that we need to form some kind of either pallets or briquette before we can practically gasify them in a meaningful way. Okay, so that's number one thing. The other challenge we noticed this semester, because the project we deal with on switchgrass, and is that chemically the composition of corn stover is very, very similar to switchgrass and Miscanthus in many senses. And the main thing I want to mention that is that it has very high content of chlorine, and also very high content of sodium and potassium. And those, as a result of those chemical elements there, that you'll be able to, you will see what we call slag happen in the gasification process. What will happen is that eventually they will build up, and you'll see some kind of a slag, and the slag will form. If you don't have, if your sodium and the potassium content is very low, and the slag you form is going to be very loose. because the sodium and the potassium content there, and they're going to form with the calcium oxide, form what we call low melting point eutectoid kind of chemical compound. In other words, they will be melted, and then they will kind of solidify together. It's like a sintering process. If you look at the geological kind of formation, it's like a sintering process. They sinter together and they form clumps inside the gasifier. And that will cause some problems with the actual equipment. And that will be an inherited problem that with the application of any gases we will deal with. But there will be solutions. We need to find a solution to how do we make it, how do we neutralize, for example, the potassium and then the sodium and chloride effects. So those will be the technical issues I think we will need to deal with. The other practical issue that is that corn store is scattered around in the whole region. And then for renewable energy, if you spend, let's just say, 1 million BTU of energy, and then you rip only 500,000 BTU, and it's not worth it. So in other words, there's a energy harvesting and a transportation issue. What it boils down, it will be a practical supply chain management issues. And those are the issues that I think is very, very critical for economics folks and for business folks to be able to tackle that issue. To me, probably that will be much, much more challenging. And people have been doing this. For example, DuPont has just started a ethanol plant in Story City, Iowa, which is about 10 miles west of Ames, Iowa. And the reason I knew was because I graduated from Iowa State and I knew their story. But anyway, DuPont is constructing a plant there that converts corn stover into ethanol. And so they have started setting up their supply chain around the Story City area in Iowa. But that can be done in the future. It is a challenge there, but it can be done. And in this area, for example, if you go to Decatur, AE Staley and ADM, they have been doing this for their soybeans for many, many years. But it will be something similar because agriculture is on an annual basis. And every year you only have one or twice. Well, in this area, only once harvest time. In other areas for rice, probably you can harvest twice. But for this area, it basically is once per year type of deal. Then you have to find ways to store them and process them. And those are the technical as well as the business challenges there. Okay. There are a lot of challenges. It can be done, but it's not easy to say, well, we can do it tomorrow, but it takes some time, takes some collective efforts. That is another example that I will see that it takes a lot of efforts from different people to tackle different issues. So, I know in your department, Chris, Dr. Langen has been working on the coastal issues.
Peter, I have a question. Is the composition, uniformity of composition, and uniformity of size of this is all critical as important? Composition, uniformity of composition, and
Yes.
uniformity of size.
Yes,
All critical.
they are. And in theory, if you look at the chemical reaction equation there, you can gasify anything, carbonaceous. As long as it has a carbon, hydrogen, and oxygen in that, you can do it. However, as I mentioned, that you will not be able to control in a consistent manner if they don't have the consistent form. Yes. There'll be much, that's one of the beauty of the petroleum, for example, at this moment, because everything we got, they are very, very consistent. The sad thing is, however, is that they only can, based upon the current estimate, we can only have probably about 40 to 50 more years of a petroleum reserve on Earth based upon the current consumption rate. Not talking about the increased consumption rate in the near future. So after 40 years, and then I will be somewhere else. But my kids probably will still face more challenges there after 40 years. But that's the reason that I think across the entire U.S., if you look at all the colleges there, all the universities are doing something similar to green or renewable energy thing because they represent the future. And our and I can see probably from conversation with Mike, I can see that his generation is much, much more forward-thinking than my generation. And my generation, I think, is better than my parents. But you will see that the next generation will be much, much more forward-thinking than Mike's generation. The point I want to make is that, I run 2 graduate programs, and we are pretty lucky that we are able to attract student interest. But from a university perspective, and we got to be able to think, at least in the synchronization with our next generations. Not mentioning about leading for our next generations and next. But of course, the university are supposed to lead our next generations. So this is one example that in terms of a forward-thinking, a forward-looking type of mentality, and this will represent EIU as a forward-thinking institution in that image there. So I think that there are a lot of implications, a lot of things that probably longer term-wise, thinking that more important than I can imagine from a purely technical aspect, because this has a long-term impact for the university health in terms of our ways of thinking for future. So, all right. So this is a kind of the research activities we can see now across the entire campus, surrounded with renewable energy type of activities. And Mike has been working with Dr. Cannon, for example. And he has been dealing with fungi and then treatment for biomass. How can we make this a more kind of easier to pelletize and then to make it more treatable and more conducive. Okay, so that it all boils down later on eventually to consistency and uniformity in the future. And Dr. Jill Deppie in biological science has been studying animal ecological systems and the impact of, say, dedicated energy crops on ecological systems. And Dan Johnson has been working on biodiesel, and Dr. Bless in chemistry has been working with us on the gasification chemistry, particularly looking at the chemical kinetics, and for example, the temperature effect on the production of gas with the grasses, switchgrass, miscanthus, those type of grass biomass. And the new faculty for chemistry, Dr. He, Hanson He, he deals with more on organic solar cells. And so it's a different front. And then Dr. Gopal Pariyana working on microbial and energy conversion. And his specialty is from sugar to energy conversion there. So, and then Dr. Clapper in biology and Dr. Karen Gaines in biological science, they have been working on biochar in terms of the analysis of the chemical composition of the biochar and then long-term impact on the ecological systems, and toxicity of the biochar in the ecological systems. Okay, so those are the kind of current activities, and we certainly we have many more, but I just list those as one example for the things going on campus. Okay. And then currently, another thing I want to mention to you also is that I talked to Mike on this here. Currently, we have started this semester to invite Charleston High School students to participate in our research activities, interacting with our undergraduate, graduate students, and the faculty member. And this is an initiative kind of started by Provost. And back to about two and a half years ago, Provost had a meeting with the school district assistant superintendents and several teachers. The idea initially was to kind of bridge between EIU and the school district and see how we can develop a collaboration, how we can support each other. But it evolves that we find out that if we can do it in a systematic way, and Eastern will have a real good conduit to channel young students' interests from this whole region and then to go into science, technology, engineering, and mathematics area. So this year we start very small. We only have 3 Charleston High School students now this semester working with us on renewable energy issues. And interesting that Mrs. Easter, she's a science teacher. She is so active and so enthusiastic, and she wants to come also. She came with those 3 students every Wednesday morning and to our facility. And so this has been very, very stimulating for me. And I use that model for I borrowed the idea from Stanford University for their MBA program. And they had a kind of informal gathering every Friday afternoon after they finish all the classes, and they gather together. And they may drink some wine or something, but we don't have any wine and cheese. But I just have activity and organize everybody, and then participate. The idea is to kind of talk to each other in a little informal way, and then so that we can stimulate more thinking and then generate new ideas. So far has been working very well for us. Okay, so hopefully we hope we have more departments and more colleges doing that in the future, collaborating with our regional and so different schools in the region. So this is my hope. I'm hoping that it will generate some momentum. Okay. So anyway, that the early version EIU had, and it was articulated by the president back to 2011, was that EIU wants to become a biomass go-to location or go-to place. And he articulated this vision back to that fall of 11 in his speech to the faculty there. So, and this vision has become closer to the reality, especially as Dr. Bahalo mentioned about the building. You'll see that it's coming to reality. Now this is the part that if you overlook from this side, overlook the renewable energy center. And the one thing I want to mention, that is that altogether this whole area north of a renewable energy center, there are about 13 acres of land. And the intention the university has is that this will be dedicated for renewable energy type of activity. Okay, so out of the 13 acres on this side, on the west side of this land, Dr. Cannon has got 4 acres. So he has planted miscanthus, poplar trees, and I think something else. Do you remember what he was talking about?
Just remember the miscanthus.
Yeah, so maybe switchgrass, I think. I know 1 acre of switchgrass, 1 acre of miscanthus, and 2 acres of fast-growing poplar trees. And so, but anyway, so these 4 acres are here. And then what do we do with the rest of it? We hope that we will expand the operation to grow more different plants as a energy co-op type of experiment plots. And then also north of this area, in this area here, and there's a construction going on right now, and we hope that will become a nuclei for the whole campus. So the groundbreaking for that construction for the building happened on March the 1st this year. And the physical activity, I think the construction probably did not start until sometime in June this year. But the president was talking about the funding possibility yesterday, and so he mentioned that the past funding crisis, the state problems, delay funding for EIU actually created some opportunity that enable EIU to allocate some internal resources for the construction of the Sincere building. And also the president was able to secure $300,000, and 1/3 of the cost for Charleston Area Charitable Foundation, because our intention to interact with local school districts and those kind of serving community and those kind of needs there are the things we are going to be engaged. So, but anyway, so 1/3 of the cost is coming from the Charleston Area Charitable Foundation. The construction, this is a picture I took about 1 week ago, and this is the site of the construction right now for the Sincere building. It's not very big, but we hope it will become a nuclear for the campus. Maybe hopefully some other wealthy individuals can donate more funding and give us more support. But the idea is that we can connect with the Renewable Energy Center as our major kind of motivation for research, and then conduct research, and then do some other things within that facility. Okay, so here's the kind of layout plan for that building. And here on the north side is going to be, we call processing and gasification area. And then this area will be, we call it analytical laboratory. So basically you will be able to process different biomass and then analyze the chemical composition, the input and output, and those kind of things there, okay, for gasification research. And then this area, 1/3 of the footage space we allocate there is what we call ideal incubator. And at this moment, the major vision we had was that we want to involve our students. And then we want to involve the private sectors in this region. And this is similar to the ideal incubators happened in Silicon Valley in California. And Stanford has played a very instrumental role in early back to the 60s. But we hope that this can become a nuclear in this region, and hopefully eventually that the whole area will become a we call energy prairie for the state. But the idea here is that we want to invite private companies here to set up their operation. We want our students who are entrepreneurs and there to work with different people and develop their ideas there associated with energy or bioenergy and some other productions there. Okay, so this is kind of a mission we have. We want to be able to outreach different the entire community. I should probably say the entire region in a sense. So with that building, we hope we not only are able to do research, educating our students, or our students learn the renewable energy concept and practices, but also we want to be able to reach the region. So those are the activities we plan to do. Actually, the Teachers Institute on Renewable Energy and the summer camp for high school students, and those are actually all part of our National Science Foundation project, and it's going to be part of that. It's going to take place next summer. Hopefully, we'll be able to do it over there. If not, we can do it in Clem Hall. So it depends on, so we don't have pressure on that. So, any questions? Comments? Okay, so that's all I have. So this is the commercial side for Sincere, but we do have a website, and just type energy. Then you will get to that website. So, thank you very much.
Any questions?
Yes, Barry.
I think this is really exciting, and I know in my own class as a student, you're absolutely right. Generations are changing, and the young students are very interested in renewable energy.
Yeah.
Definitely, we're in an area where biofuels are an advantage.
Mm-hmm.
But the other energy source that's really growing in Illinois right now is wind.
Mm-hmm.
And I have a group in my GIS class right now looking at a wind energy project. I was just wondering what you thought the role of a university like EIU might be, or of Sincere in looking at other sources such as wind.
Yeah. Certainly Sincere, with a sincere vision that we do not want to limit ourselves in biomass only. And we will be open, say, for research. We need more people to do those. And for example, we have one faculty member in technology, Dr. Slavin. He has been working on wind aspect. And then also we have faculty devoting efforts on solar energy as well. So those are all part of the spectrum. And in the energy, for the energy problems, there's no panacea. That one pill can solve all the problems. No, it really depends on we call spectrum of solutions. So wind will be in a sense, wind will be part of our interest. However, though, if you look at the landscape in the state of Illinois, and we did not start with wind, the reason is that if you look at the landscape. If you go to southern Illinois, Carbondale has been known for their coal research in the country. U of I, north of us, has been known for their research for ethanol production, in a sense, because they have an agriculture college, and then so ever since they have the college there, and they have people who deal with food sciences, and then they eventually do ethanol and those kind of production there. And then on the western side, and we don't have much going on, but Illinois State University, and they started earlier than us. And so they formed they call Center for Renewable Energy. And so because of the McLean County there, you see there are, I think at least I know there are 2 visible wind farms, not very far from Bloomington normal area. So they use that as their niche. And so at this moment, I don't see any companies setting up a wind farm south of Charleston because the geological forms are different. It's not as flat. And so I can see that there's no reason for us to compete with Illinois State looking at, for example, on the wind. But I don't think they got much into that either, because once the wind farm is established, there's not much you can do. But they are closer to that, and so they tend to study more. I know Dr. David Loomis, he's a director over there for their Center for Renewable Energy Center, and Center for Renewable Energy. And he's an economist. And he deals with quite a bit kind of a study in early years, maybe back to 4 or 5 years ago, dealing with more, say, the feasibility of a wind in that region and in the whole state of Illinois. So to answer your question, that we have interest in, but I don't see us developing a good niche right away. It may take some time. It may never happen, but certainly from looking at the energy perspective or spectrum perspective, energy, wind energy and solar will be to our interest. So.
Peter, this should be very interesting to international students, especially Asian countries,
Yes.
to bring this come here.
Yes. Yeah, it takes some time for them to know the programs. For example, that in the graduate programs I manage called Master of Science in Technology, and this program, then altogether now we have 171 students this semester, and we have about 90 international students, and many of them knew the program because we have a component called computer technology, because they came to U.S. looking for computer technologies programs, and so that I'm hoping that the sustainable energy program eventually will establish ourselves in terms of name and reputation, and students will come for that interest. But certainly you are right that especially in Asian, well, I think it's actually not necessarily Asia countries, but also Europe and South America. Many other countries are leading. And for example, in US, compared with US, we have such abundant resources. People sometimes don't appreciate it. But in other countries, bio resources are so scarce, and so they tend to value more on those here. So they put more emphasis and more. But so those countries tend to put more, I'll say, weight on their research on renewable energy. But this becomes eventually I think will become a human survival issue. So eventually we'll come to that point. So it will become more and more important. That's why we need to educate our new generations so they know, and then when they become politicians or anything, decision makers in the future, they can make wise decisions for the human race in general. Because I remember that you can remember those probably, I did quite a bit of recycling efforts back to early 1990s on campus. So at that moment, just back to 20 years ago, and I had to tell you the truth on that, recycling was a very, very new concept back to 20 years ago. But now with Mike's generation, recycling is just a routine thing for them to do or to recognize. So it takes some time for us to educate the kids, and then eventually they'll become more educated and more aware of how we can protect and preserve the natural resources.
I know you said that during your presentation, but what is the relationship material-wise with the Energy Center and the Sincere? I mean, I know they get their raw material to do the heating and so forth.
Yes.
And Sincere would take the residue, or what is the relation?
That there are two major missions. That the first mission we initially got was that, or we sensed that the renewable energy centers gasifiers and are designed to consume only wood chips. And wood chips are much more consistent in terms of energy values and internal control. But you look at this area, this is as Barry mentioned, this is an agricultural land. This is not a forestry. And if you go maybe 100 miles south of here, you go next to Shawnee National Park, maybe you're okay. You will have lots of forestry resources. But in this region, we don't. And so if you look at the resources in the future, and the bioresource particularly, and we have to depend upon agriculture. And so in other words, we got to find some alternatives to the wood chips in the future. That's a long-term thing. But in order for the university to be able to position ourselves to consume, to use, say for example, corn stover, we got to do some research, we got to do some testing, we got to find some data, we got to pull people together to make it work. So that's really, to me, it's a very urgent thing, and even though we don't realize it, it's very urgent for us to find alternatives and to sustain the operation in the future. So that became, initially there was a very, very early vision for Sincere. Let's go ahead, do some research. We cannot emulate BP Amoco, for example, a big corporation, but they have their research and development laboratory in Naperville, in Chicago area. And this research and development will support their operations in the field, and down to Houston or different places. So we hope that in an initial stage, we hope that Sincere can serve as a research and development arm for the university and support the real mission of the Renewable Energy Center. That was what I was first thing. And then after the Renewable Energy Center is in operation, we realized that not only to support the fuel selection, but also we need to find out systematically deal with the ash, for example. And so the ash project we had just at the beginning that we need to deal with them systematically in the future, including ash and possibly in the future emission controls. So those will become a kind of research motivation for us to do.
I have a question that I know that it's not us to talk about. It's the term renewable energy. We didn't invent that or coin it. It's just the way it is, renewable energy. But just trying to think linguistically, is it the energy that's renewable or the source of energy is renewable? Because energy goes, I put a source, get energy, and energy is used. So yes, the energy doesn't dissipate, and the law of thermodynamics, I mean, matter and energy doesn't go away, I mean, just transform. But if you get some source of heat, the heat is energy, and the energy is used, and by you see it became something else. So is it a renewable energy, or I can bring another source of energy, and this is the renewable?
You are absolutely right. I think if you look at this here, it's a source that's a renewable. And we can also argue that even coal, petroleum, they are also renewable because they came from the biological source but in geological kind of time scale. So that's a very, very long stretch if you say it's a renewable also. But to go back to your question, it's a source that's a renewable. Yes.
One of the reasons why I get this ideas in my mind is I see our society is kind of accepting the buzzwords as is. For example, if you say illegal immigrants, it became a household name, illegal immigrants. So when you hear that some illegal immigrants will become lawyers, yeah, okay, they practice law. I mean, why they're illegal immigrants? It doesn't, we got numb to something. Or, oh, he died with friendly fires. Oh, okay, it's all right, as if it is all right to die by friendly fire. Die, I mean, see what I mean?
Yeah.
This kind of, or just yesterday I heard about the Church of Atheists, the Atheist Church in India. So why is it that we use terms and just confuse people?
Paradoxical.
Call it something else.
Well, this is an example that a foreigner like us pay attention to the language. I was joking with my students, for example, that after coaching my younger daughter for National Spelling Bee for 2 years, I developed a habit that I had to, for everything I don't know, I had to look at the dictionary.
Yeah.
And my students don't do it. And so when I was teaching my management subject, I was asking them, so what is the vision, what is the mission? And some of them don't know. I said, you look at the dictionary, you will see better if you do. And so this is the thing that we pay more attention because we don't know what's going on.
Now you will laugh at this.
Yeah.
When I say